Bismillahirrahmanirrahim. What is time? Conceptual and mathematical explanation. Time is a fundamental quantity in physics. It is denoted by T. Okay. Denoted by T. It measures the sequence of events and duration of events. So this is in fact the definition of time, that it gives sequence to events, one events after the other, and it measures the duration of events. So let's understand this. In fact, it is order. So time give orders to events and duration of events. Order of one events. So there is a starting point, start of the events and end of the event. In between it is duration, and you see this is order. You will never see the end before the start. So that is time that give these two things to the event, start and end. So it will be in this order. This will first and this will last. You will never see the end before the start. So that is time that give this order to the events at starting and ending. For example, we have a cricket match, so there will be a toss at the starting and winning or losing after this. So toss is, you will never see the winning or losing before the toss. So toss is the starting, and then there is a duration of the match, and at the end you will see winning or losing. Okay, so that is the time that give this order. You have start and you have ends of the event. So it order one event in this way. It will be there will be a starting and there will be an ending. Order of many events. So events come in order. Event 1, event 2, 26 start with January. So it's starting January, then is February, and March, and so on. So consider January is an event. This is the first event. Then February is the second event. March is the third event, and so on. So it never happened that March will come first and March will come before the February. March will come after February. That is order of the time. It gives the order to the events. So event come in orders. So that is time that give order to events. One events come after the other. And so the time, what is time? Time order the events. One order to one events, and to many events time gives order. Okay, time is not absolute. So Einstein special relativity changed the classical concept of time, that time is not absolute. It depends on motion. relative motion. So the time for a stationary and moving observer are different. Stationary observer measure different time than the moving observer. So one observer is stationary, the other observer is moving in something that is moving, so they will record different time. The moving observer observe time dilation, and we will see it. So the clock of the moving observer slow down. Higher the velocity of the observer, more slower the clock of that observer. Okay. What is proper and improper time? So let's understand this concept, proper time and improper time. So for this we have to take an experiment. We have a ship, a man inside and another man outside the ship. This is stationary observer, and this ship is moving with velocity v in this direction, and this man throw a ball up in the ship, okay, but also moving forward. So when the ball reach the top, the ship reach at this position. The ball reached the top at this position. So the observer inside the ship says that the ball moves in a straight line to the top of the ship, the ceiling of the ship. But the outside observer say that the ball moves in this direction. Okay, so both give different observation to motion of the ball. Okay, so we will see the different time or proper and improper time from this experiment. Let's say this ball is the light of the torch. The torch is on, the light goes up and reach the ceiling of this ship. So the inside man says it is straight away goes to the ship, to the ceiling of the ship, but the outside man says that, observer says that the light moves on this path. So the time the light take time to follow this path and reach the ceiling is tau, t, this t. So this is dt, time taken by the light to reach from the bottom of the ship to the ceiling of the ship. If I multiply it with this, because this is the light, particle of the light, so I will multiply it to the velocity of the light to get this distance. So let's name it, this is position A, position B, and this is position C. So the light reach from A to B in time dt with velocity c. So when I multiply the velocity with time, I will get the distance. And this man says that the the light from the bottom to the ceiling reach at with time d tau to the ceiling. It is light, so the speed is c in both cases. So this is the distance BC. This is the distance AB, and this distance is x. This is let's say along x-axis it cover triangle ABC is right angle triangle. Okay, so Pythagoras theorem will apply here. That means the distance CDT square should be equal to the distance CD tau square plus x square. Okay, rearranging it, it is c square d tau square is equal to c dt square, c square dt square minus x square. Write this O. Let's take it everything in d. So this is dx, this is dx, this is dx. Okay, so this is this formula, but let's divide on c square. So d tau square is equal to dt square minus dx square over c square. So you see, we call the time d tau is proper time, the time taken by the light to reach on this straight path, which is the observation of the inside main. The time taken by the light to reach from the bottom to the top is called proper time, and the time taken by the light to reach from A to B on this path, that is improper time. So d tau is proper time and dt is improper time. Okay, now you see two part of the proper time, improper time and space karo or space. Okay, so this is proper time and this is improper time. So proper time is a mix of the time and space. Proper time is a mix of the improper time and space. So that is why we call space. So the name space-time came from this concept that the time, proper time, is a mix of the time and the space. Okay, so if you need a proper time, then you have the improper time and subtracted this geometric term. This is length. And in a three-dimensional space, this take this form: dt square minus dx square dy square and dz square whole divided by c square. So this is the full space-time metric. it gave us, this is the time noted by the man inside the ship, and this is the time noted by the man outside the ship. This is the time passed in the clock of the inside man, and this is the time passed in the clock of the outsider. So the proper time, if we need the proper time, either we have to take this value 0. That is possible only when when the ship is at rest. If the ship is moving, then the proper time will be a mix of the time and space. So the space and time intermingled give us a proper time. Okay, thank you.